Okay, so here we're going to differentiate a log function, and we have y equals the natural log of 3x squared minus 2x minus 4. If we differentiate y, we're going to get dy dx. Okay, now the basic rule for log, differentiating a log, is that you put 1 over whatever follows log. So it's going to be 1 over 3x squared minus 2x minus 4. But remember, just as we did with exponentials, we now have to multiply this by the derivative of whatever followed the log. Okay, so we're going to multiply what we have here already by the derivative of whatever followed the log. And again, because there's more than one term here, and there's going to be more than one term in our answer, we're going to have to put this part of our answer in parentheses. So now differentiate 3x squared gives you 6x. Differentiate minus 2x is just minus 2. And differentiate minus 4, well, that's going to become 0. So your answer is 6x minus 2 over 3x squared minus 2x minus 4. And that's the answer. Okay, that's that problem done. But now that I've got you here, I want you to look at a different type of problem here. I want you to consider these two types of log problems that are coming next. Let's say y was equal to the log of 5x, and we had a different y over here, different problem. Let's say log of, I don't know, pick something random, let's say 12x. Okay, well, let's use the laws of differentiation, the rules of differentiation on these. And if we differentiate y, we get dy dx. If we differentiate log, we get 1 over whatever was here, so that's 1 over 5x. And then we multiply by the derivative of this part, the derivative of the part that follows log. So the derivative of 5x is 5. Now if you do that, you'll end up with the 5's cancelling, and so you get dy dx is equal to 1 over x. Okay. On this side, something similar happens, dy dx. If we differentiate log, we're going to get 1 over whatever comes next, 12x. And then we have to differentiate the 12x. That's going to give you 12. And the 12's will cancel, and you have 1 over x. So it presents us with a rather tricky problem. We started with two different equations, but we've ended up that they have the same derivative. So let's see how that makes sense. Imagine that you have y equals log of 5x. Well, one of the rules of logs is that that can be rewritten as y equals the log of 5 plus the log of x. Okay? Now, if we go to differentiate that, the log of 5 is a constant, so it becomes 0. The log of x is 1 over x by the derivative of x, which is just 1. So dy dx is 1 over x. And you can see that if we repeat this with 12x instead of 5x, that something very similar is going to happen. Use the rules of logs to write this as the log of 12 plus the log of x. Differentiate. The log of 12 is a constant, so it becomes 0, and the log of x is 1 over x times 1. So dy dx, again, is 1 over x. So when we do it initially, and this is the way, the top way here that I've written is actually the way you're going to do it, but initially it might be problematic to you as to why we end up with the same result from two different starting positions. But if you remember about the rules of logs, the log of a product can be written as the log is the sum of logs. Okay, so the log of a product can be written as the sum of these logs. And that's what makes this work, and which is responsible for the two different original equations giving us the same derivatives. Okay.